So I'm going to be talking about the sensory system. First up, what is sensation versus perception? This is a little bit of vocabulary. There's a little guy smelling cake here. So sensation is the conscious or unconscious activation of sensory receptors, and these are special types of cells that get stimulated, and they create an action potential that will travel along our nerves to the brain to be interpreted. In our little drawing, that would be the smell of the food entering the nose and being sensed there. Perception is the conscious awareness of a sensation, so that's the brain getting those signals from the nose and knowing that that's cake. So the first sense I'm going to talk about is temperature. The receptor responsible for temperature are called thermoreceptors. There are cold and hot thermoreceptors, different ones. The cold are stimulated at 50 to 76 degrees Fahrenheit, hot at 76 to 112 degrees Fahrenheit. Anything outside of this range is actually pain receptors are being stimulated. And then the temperature receptors are very rapidly adapting, and so adapting is another vocabulary word. When sensory receptors are stimulated for a long time, they can stop sending as many signals to the brain, so you won't feel that sense as much. Another sense is pain. These receptors are called nociceptors. They have many different triggers. I'm just going to go over a few common ones. One is that chemicals are released when your tissues are damaged. That triggers nociceptors. Two, oxygen deficiency in those tissues can trigger nociceptors. And three, stretching and deformity of those tissues can trigger the nociceptors. An important fact is that pain does not adapt. That pain sense will not adapt. Touch and pressure is another sense. These are due to mechanoreceptors. This is the first sense that we develop as a fetus, as a fetus. And these are found in the skin all over the body, but the densest concentrations are in the fingers and the toes and the penis and the clitoris. Another one is proprioception. The receptors here are mechanoreceptors located in the muscles, tendons, and joints. I just realized I have a spelling error there. I'll fix that on my notes. This is our sense of orientation and position, so that we can close our eyes and touch our nose. We know where our body is. Next, we have the sense of smell, also called olfaction or the olfactory sense. The receptors here are chemoreceptors. They're stimulated by differences in chemical concentrations. So the chemicals enter the nose and they dissolve in the moist tissues of the upper nose. That's how we're smelling. Another chemoreceptor is a taste receptor. This is called gustation. These are located in our taste buds. And the taste buds are found on our tongue, on our tonsils, and even on our throat. We have hearing. This sense of hearing is also due to mechanoreceptors in our ears. Pressure waves that are in the air, they enter our ears and they start vibrating all the different things like the eardrum and the little bones, and that makes its way to the cochlea, which have little hairs in them. And when those hairs move, they stimulate mechanoreceptors, which put that information to the brain, which can then translate it to sound. Also in the ear are mechanoreceptors that are responsible for our sense of balance. These are located in the semicircular canals up there on the top, and this can tell when our head is moving or what position our head is in, and helps us maintain our balance and our posture, both when we're moving and when we're standing still or sitting still. And then finally, we have sight. The receptors here are photoreceptors, very specialized types of cell receptors. There's two different ones, rods and cones. It's important to know the difference here. There are a lot more rods in our eyes than there are cones. Rods are good in low light, but they only produce black and white vision, whereas cones are responsible for our black and white vision, or our color vision, and they have higher visual acuity. I want to show a CT scan here of kind of what the eyes will look like typically. Well, maybe not so typically. On the right here, We have an ocular globe, which is the eye, and then if you look close, you can kind of see the lens that is actually refracting the light and focusing it onto the back of the eye, which is where the retina is, which is where the rods and cones are. And then on the left here, it looks a little weird. This is actually a malignant melanoma of the eye. Very interesting. So I'm going to attach these notes to my webpage. Thank you.